Okay, so on these, we are naming each of the parent functions, and then we're going to draw a graph of them, and then we will look at the domain and range, okay? Domain and range being in both ways. Now, this one's the one you should have learned in Algebra 2. It's the linear function, okay? Straight lines. The linear function, the original y equals x, looks exactly like this. Okay, big deal that it goes right through the origin and then has a slope of 1 and all that, right? The next one that you also did in Algebra 1 is the quadratic. Y equals x squared. I'm not sure where they come up with this name or why they make this name instead of just calling it x squared, but or whatever. This is the one you did over and over again. It starts at the origin, goes up this way, goes up this way. Okay. The quadratic looks exactly like the one that's x cubed, right? This is a cubic because it's cubed. All right. I like to relate these two together because the quadratic and the cubic start out and they sort of look the same. If I'm graphing it, and again, you can always have a calculator, so putting y equals x cubed, that's pretty easy. But I can put that in there and it looks like this. A little bit tighter than this one because you're cubing it instead of squaring it, so the numbers get bigger faster. But on the negative side, as x goes negative, now I can actually have negative answers. So it looks like that. Okay? On the quadratic, when I square something, a negative number times itself, that's negative times negative, is positive. Okay? But it looks like this, it curves up, but on the negative it goes down. Now, the square root. You've seen square root before, right? You've seen that before. That one looks a lot like the one down here, and you were never really taught this, but square root actually has a 2 in there. This right here changed the number. So if this is the square root, this, because it's to the third power, would be a cubed root. And when I graph them, now remember, if I put a negative number in the square root, I get an error. So we cannot have negative numbers on square root. So that one starts here. Square root of 0 is 0. And square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. So this one goes like this. Sticking with the same idea, the square root looks like the cube root. Okay? It's the cube root, so it goes a little bit faster, but still 0 is 0. 1 is 1. And then from there it gets a lot tighter. And I didn't really make it look tighter, but it's really, really short and fast. Now the difference is on a cubed root, I can have a negative answer. So this one looks the same the other way. Okay, so squared, cubed looks the same on the right, but just slightly different. Changes on the negative side. Square root, cubed root looks the same on the right, different on the negative side. All right, let me turn to the back page. This one's a little bit different, but this is called absolute value. Most of you should know about that one. Okay, the absolute value is like the linear on this side. However, absolute value cuts off the negative, so you cannot have negative answers, so it goes up on this side. E to the x, this is also written as 2 to the x, right? This could be f of x equals 2 to the x. Sometimes they write it like that. Either way, we know this one that x is the exponent, and that helps us with the name. That is an exponential. Right? The exponential, a lot of people talk about exponential growth because it grows really fast. right? We talk about like bacteria and things like that growing really fast. So it starts out low, goes like this, and then just grows real fast, right? And goes on that way. This is the first one where we draw a dotted line right here at the axis, and this is an asymptote. An asymptote is a line that it never touches. Okay, so this graph is going to get really close to the axis, but it's never going to touch. Right here, most times this is written as log B, but we normally go with log base 10. So if you need a number to put in your calculator, you can put a 10 in there. This is a logarithmic function, but most people just call it a log, right? The logarithmic function, I tell people, looks like an L, but it starts down here, goes really close, and then curves this way. This again has, just like up there, an asymptote. Okay, and then this one right here, we call this a rational. That is the fraction, so the x is on bottom of the fraction. Sorry about the people next door. And this one, it's easier when you draw that it has actually two asymptotes. It will not touch either of those. So I'll put right here, asymptote, and right here, asymptote. Okay, but if I have these two asymptotes, on the left side it's a U shape. I mean, on the right side it's a U shape. On the left side it's a U shape. So it gets really close to this line here, really close to that line there. It skips it, and then goes really close to this one again. So if I follow this asymptote, it gets close on this side and that side. If I follow this asymptote, it gets close on this side and that side. Okay? So those are the names in the graphs. Make sure we write those down.